Hello. I am continuing the repair of the 3D 722 surface grinding machine. Without watching the previous episode, the logic behind my actions might be unclear. Please watch the previous episode if you want a complete understanding. I am repairing a pair of linear movements 3 meters long using an autocollimator as the key measuring tool. The autocollimator will ensure the linearity of this guideway. It's quite challenging to imagine a 3-meter straightedge, even more so to work with it, especially without assistance. While it's not impossible, using an autocollimator allows me to achieve the goal more easily and with higher accuracy. I will need a support for the autocollimator mirror about 1 meter long and a straightedge bridge also slightly over a meter long. I could use, for example, a half-meter support for the mirror and a half-meter straightedge, further easing the strain on my back and arms. However, I have decided that handling meter-long accessories is within my capability. After all, taking measurements in 3 positions will be slightly more accurate and simpler than in 6 positions. In the previous episode, I preliminarily created base segments approximately 5 centimeters long on the guideway, located half a meter to the left of the center, which I called B1 and B2, and similar segments half a meter to the right of the center, named C1 and C2. These segments, having been scraped to match the prisms of the autocollimator mirror support, which have precise surfaces, lie on 2 imaginary ideal planes. I named these planes alpha and beta. These segments will serve as beacons during scraping. Subsequently, similar segments will be created at the edges of the guideway, relying on the autocollimator's readings. I named these segments A1, A2, and D1, D2. Together with segments B1, B2, and C1, C2, they will bring the guideway strips to the correct linear form by removing the protruding material between these beacon segments. The protruding material will be identified by paint marks from the meter-long straightedge bridge. This scraping process will culminate in reaching the alpha and beta planes along the entire length of the guideways. Now, the logic of the repair poses the next question. I have already created the beacons, so the imaginary planes have taken their positions in space. But how do their positions relate to the vertical guideways? How close are they to a 90-degree angle? This is important, though not crucial as it would be for a milling machine, but still significant. Having the answer might lead me to adjust the positions of the alpha and beta planes by deepening the relevant beacons from the B or C groups. As a result, I will approach the correct 90-degree angle relative to the vertical guideways without making unnecessary efforts, as it is equally easy for me to cut more from either the right or left side of the guideway, tilting them towards a position closer to a 90-degree angle. Thus, the overall workload will not change significantly and may even decrease. So, I am measuring how precisely the horizontal feed, currently still imaginary, passing through segments B1, B2, and C1, C2, aligns with the vertical feed. Here's how I will perform this procedure. I need a reference angle of 90 degrees, with one side measuring at least a meter, as the distance between the supporting segments B1, B2, and C1, C2 is 1 meter. I currently do not have such a reference angle. However, this is not a problem. I have the necessary minimum, a reference straightedge of sufficient length, verified and very accurate, which, again, is not a necessary condition since accuracy beyond 0.01 mm is unlikely to be needed here. I have two supporting cylinders, formerly bearing rollers, whose diameters correspond to the guideway size, and their geometry is accurate enough to be used as supports for the square on sectors B1, B2, and C1, C2. I also have an old reference angle, which is not accurate and has been heavily used, especially by welders. But its longer side is exactly 1 meter. It will serve merely as a frame for mounting my reference straightedge and two supporting cylinders. If I didn't have it, I would have simply welded something similar from two square tubes, which would be sufficient. If I had an accurate reference angle of 90 degrees, one measurement would suffice to understand the vertical feed's position relative to the horizontal feed. Since such an accurate angle is unavailable, two measurements instead of one will compensate for the lack of a precise square by using the second, opposite measurement, thus providing accurate information about the angle between the longitudinal and vertical feeds on this machine. Now, let me demonstrate the step-by-step methodology. I will glue the supporting cylinders to the frame of the angle to create supports at points B1, B2, and C1, C2 on the guideway line. To apply glue and ensure sufficiently reliable fixation of the supporting cylinders, additional pads were made for the angle frame. The supporting cylinders have some freedom to adjust their positions while the glue is still plastic, orienting themselves to the support points B1, B2, C1, C2, ensuring their proper positioning during adhesion. I am not concerned about the polymerization process of the epoxy glue causing shrinkage. Shrinkage has certain characteristics, which I have separately studied, and I will not delve into this here, but I have grounds to believe that this characteristic of epoxy glue will not affect the positioning of the supporting cylinders, allowing them to fully interact with the supporting sectors B1, B2, and C1, C2. Therefore, I use epoxy glue and attach the supporting cylinders to their respective places. Thus, my angle gains supporting legs. I have assembled a simple supporting structure that secures the angle in a vertical position. The next step is to attach my reference straightedge to the vertical arm of the angle. Two clamps will facilitate this operation. I created the possibility to finally adjust the angle of the reference straightedge using a support screw. I quickly reached the state where the straightedge became parallel to the vertical feed. This is confirmed by the indicator needle staying at 0 while moving the carriage over its entire range. The next step is to carefully rotate the angle 180 degrees. Secure the indicator for the second measurement accordingly. Now, move the carriage downward, and everything will become clear regarding the angle between line B1, B2, C1, C2, and the vertical feed. The indicator needle showed a movement of 0.26 mm when the carriage traveled down 300 mm. Since this is a double measurement, the result must be divided by 2. Thus, here it is, the inclination of the vertical feed, 0.13 mm over 300 mm. Conclusion: if possible, during scraping, should cut more from the left side of the guideway. This way, I will not only create straight guideways but also bring the angle between the horizontal and vertical feeds closer to 90 degrees, improving the overall geometry of this machine. If it were a milling machine, would have to achieve a full 90-degree angle, but on a surface grinder, I am satisfied with getting closer to it, which is quite sufficient. Agreeably, it is undesirable to move away from this angle during the repair, which would not have been ruled out without these measurements. To ensure I haven't disturbed the assembled angle when turning it 180 degrees, and to confirm that this measurement is indeed accurate, it makes sense to verify it with a third measurement by returning the angle and the indicator to the initial position. If parallelism is observed again, I can be confident in the obtained result. So, no doubts, the measurements are accurate. Since I installed the indicator on the carriage and have all necessary devices nearby, I can additionally check the state of the vertical feed regarding the backlash between the carriage and the column. The linearity of this feed, not exceeding 1/100th of a millimeter, was already observed when aligning my straightedge parallel to it, i.e., parallel to the vertical feed vector. I must note that in this feed, the carriage moves on rollers, so I can hope that its geometry is well preserved. The first measurement is conducted at the upper part of the carriage travel. The indicator has a resolution of 2 microns. In this part of the guideway, minimal wear is expected. Indeed, there is no backlash. Lowering the carriage. Still no backlash. Lowering the carriage further. Approximately here, maximum wear is expected. Indeed, slight backlash appeared. But it is close to 1 micron. The condition of the vertical feed, which operates on rollers in this machine, is good. The condition of the spindle's cross-feed is significantly worse, as expected. But this is not a big problem, which can be controlled and, overall, can be analyzed later. So now I know the inclination of the vertical feed relative to the supporting sectors B1, B2, and C1, C2. Based on this data, I need to find the optimal spatial position for the alpha and beta planes, a position where I can create straight guideways by removing the minimum amount of cast iron from the machine's body while also approximating the vertical feed's angle to 90 degrees. In the next episode, according to the repair plan, I will adjust the sectors B1, B2 and create sectors A1, A2, and D1, D2. All of them will be aligned along the alpha plane and along the beta plane. Right now I'm leaning towards making the guides completely straight. Although the instructions for this machine indicate the desired. A gradual reduction downward by 1/100th of a millimeter of the guide in its center, taking into account its expansion from heating in operating mode. But there is still time to think about it and make an informed decision. I am pleased with this stage of work. Of course, there is a lot of work ahead, but if I can handle it, then I will get from the machine excellent accuracy and smooth operation, which it certainly deserves.
Thanks for your support through Patreon.
I am pleased with this stage of the work. Of course, the hardest part is ahead, but if I manage it, I will receive excellent accuracy and smooth operation from the machine, which it certainly deserves. Please like and subscribe if you found this video helpful. Thank you, and see you in the next episode. Goodbye.